What's up, folks? Thanks a lot for checking out my talk. Today we're going to be talking about linting, as I often find myself doing. My name's James Henry, and I created TypeScript ESLint and Angular ESLint, and I spent a while on the ESLint Core Team as well. So it's definitely something I've been thinking and working hard on for a long time. Another thing I've been thinking about a lot and working hard on is NX itself. I was the 5th employee of Narwhal back in December 2017, and it's a critical part of everything I do in front-end development. What I'm excited to cover with you today is a brand new capability we added in version 12.9 of NX, namely the ability to develop ESLint rules in your workspace and use them in that exact same workspace with no interim packaging or publishing steps required. If you've ever wanted to enforce the best practices and conventions you have in your team or your NX workspace using tooling, then this talk is for you. This is a very practical talk. There are no slides here. We're going to dive straight into a screen share where I'm going to walk you through developing a lint rule from end to end. Everything I'm going to cover applies to both existing workspaces and new workspaces, as long as you're on version 12.9 of NX and above. And it also applies to any and all presets that NX supports. So it doesn't matter if you're using React, Angular, or anything else. Everything I'm covering applies to all of you. So with that said, let's get straight into it and build a lint rule. Let's run create NX workspace as usual. I'm going to pick the Angular preset for now, and we'll just choose CSS because it makes no difference for this. NX Cloud is not required for any of the elements of this talk, but I highly encourage you to check it out if you're not familiar with it. Let's speed through the dependency and creation process. And now we're up and running with a brand new workspace. Let's jump over to VS Code. Of course, one of the great things about NX is the fact that it sorts us out with all of the commands we care about immediately after we've generated the workspace. So for example, obviously linting is very important to this talk. We're going to run ESLint, and everything is already in place for us to do that and have things pass for the my app application, which I generated as part of the command. And of course, it's invoking the linting in accordance with the configuration files, the .eslintrc.json files, which have been set up in the workspace again automatically for us by the generators. So when we look through the configs, we can see that different files are being targeted with the overrides. We have rules such as the one provided by NX out of the box called enforce module boundaries, and everything is in place that we need both at the root level and at the app level. In the my app, we also have the config which extends from the root and applies some specific things which are relevant for the type of project that we have in place here, in this case, Angular. So let's close out these config files, and a lot of the rest of this talk is actually going to focus on the tools directory. You might be familiar with tools because it's automatically populated with a generators directory, which is relevant if you're creating your own generators for your workspace. Here, however, we're going to be leveraging a very new capability in NX introduced in 12.9, where we can generate our own workspace lint rules, which will also live in this tools directory. In order to do this, we are of course going to be running a generator, so we can run this via the CLI using nxgenerate, or its short form nxg. We're going to be invoking a generator from the narwhal linter collection, so that comes before the colon there, at narwhal/linter, colon, and then the name of the generator, which in this case is workspace-rule. And as always with the NX commands, we can pass --help to get full information about the arguments that that generator will take to help inform its generation logic. This of course works great, but another awesome option is the NX console extension, which is a VS Code extension which I have installed over here, and I can use to invoke generators as well as many other capabilities of NX using a graphical user interface. Now that we're on this screen, we obviously have the ability to give our rule a name. So let's think about what we're going to build today. You might have worked on a project in the past which used a convention around naming of variables. For example, if you have a set of constants, it's quite common to have a convention that you name those constants using uppercase letters only. If you only enforce those conventions using human beings in pull requests, that's obviously a bit of a drain on resources for something that's so simply enforced using programmatic means, such as a linter. So let's create a rule that will enforce that our variables, specifically our const variables, are going to be written in uppercase so that we get the benefit of feedback directly in our editors using the ESLint extension for VS Code or for WebStorm, etc., and that we get the benefit of catching it in CI automatically using NX affected lint, for example. I think a reasonable name for this rule would therefore be uppercase const. So let's type that into the box. And the great thing about NX console is it's immediately going to run the command that we would be running if we confirmed this, but using the dry run flag. So it will show us, it's going to create all these files that show us exactly where they will live on disk, but nothing has happened because the dry run flag was passed automatically. And this won't change until we click the run button. By clicking the run button, we've actually invoked the generator and it's actually applied those changes to disk. So we can see, as well as those files that it's created, it's actually given us a log reminding us about all we've done so far is generate the scaffolding for the rule. If we want to enable the rule in our configs and to actually have it take effect during linting, we need to specify the rule in our ESLint.rc.json files. Now, normally the way that ESLint would resolve rules and plugins is to look for packages inside of your node modules. This makes perfect sense, but it does come with the downside that you have to come up with a packaging and publishing logic for your rules in order to make them accessible in your application configs. This is particularly cumbersome when we're dealing with a monorepo like with NX, because all of our code lives together. That's a great advantage of the monorepo. So wouldn't it be nice if instead we could have our lint rules written locally and also leveraged locally without any interim publishing or packaging step? That's exactly what this new feature in NX 12.9 gives us. We have this kind of magical namespace that comes after the @narwhal/nx ESLint plugin, which will specify that we want NX to resolve from our ESLint rules project that was just generated for us, and anything we give thereafter is the name of our specific rule that lives within that project. So here, in my case, uppercase const, my rule name, is resolved kind of magically by using @narwhal/nx/workspace and then my rule name of uppercase const. So let's close all of this generator output for now, and we can take a look at the end result of running that generation logic. We can see that the new project called ESLint-rules, and that name is important. The generator will always create a project called ESLint-rules, and that is the project that the NX ESLint plugin magically knows to resolve and link to that workspace namespace we just covered. So that project has been generated for us, and we can take a look at its files. It looks very similar to a lib you might be used to generating with NX, but it's very focused on its specific use case of being effectively a local ESLint plugin. And with that in mind, the key element of an ESLint plugin that you need is an index, and that index creates the mapping of rule names to the actual implementation of the rules. So that's exactly what we have here as well. That's what NX has generated for us. As you can see, it's also generated some helpful comments in line to help document what's happening here, and it applies some comments to help you add to this over time as well. So I'll give you a reference down the bottom there to the generator that you can run to create a new rule, which will automatically add imports and the relevant exports to the rules. And then if we take a look at the implementation of the rule that was generated for us, again, we will see lots of helpful documentation comments in line. We'll see a nice reminder of when we actually leverage this rule, that we have to leverage it under that narwhal NX workspace namespace. And we can see the actual implementation of the rule. Right now, this implementation does nothing, but it's a valid implementation of a rule that does nothing. So we could use this in configs right now, and it would technically work, although it won't provide any feedback on any situations for us yet. As well as the valid implementation, NX has also scaffolded a valid test file for us. So we're leveraging the rule tester, and the rule tester is very specific to testing ESLint rules, which allows us to provide a set of cases which would be valid under the rules constraints and also invalid under the rules constraints. So obviously NX can't know from the generation exactly what our rule is going to do, so it can't possibly scaffold applicable valid and invalid test cases. But what it can do is it can generate an example that is executable by the test runner and therefore gives us a great starting point to adapt to our needs. Naturally, the test runner of choice is Jest here, so Jest has also been wired up for us, and we already have a test target ready to go on that new ESLint rules project. So we can actually run that straight away now. We can run nx test ESLint rules to invoke Jest and run that on that spec file that was generated for us. And that's really all there is to it when it comes to the generation logic. With a single command, NX has generated a valid scaffolding for effectively an ESLint plugin for us. The ESLint rule implementation is also valid, and we have the test runner set up, ready to go with a valid executable spec file. So we only need to focus now on implementing the rule as it fits our needs. If you've ever implemented an ESLint rule in the past, you can bring all of that knowledge to the equation now. There is nothing NX specific in the implementation logic. It's purely on the usage with that magic resolution I mentioned in your config naming. But apart from that, everything we write in the implementation of the rule is standard ESLint stuff, meaning we can use the official documentation and any existing utilities that exist in the ecosystem, for example, from TypeScript ESLint, in order to write the rules how we need to. I've switched over to the browser now, and I'm visiting a site called astexplorer.net. When it comes to writing lint rules, astexplorer.net is a lifesaver. It's an interactive tool that allows you to write source code as input on the left-hand side and see your program visualized as an AST on the right-hand side. If you're not familiar with ASTs, they're a core primitive data type that is used to power almost all of the front-end tooling you're used to, such as TypeScript, Webpack, Babel, and many, many others. ESLint uses ASTs as well. AST stands for Abstract Syntax Tree, and it allows us to represent the program that you've written not as free text, which is easy for humans to understand, but not so easy for machines to operate on. And it instead represents it as a data structure, and we can visualize that data structure in a couple of different ways. A simple way might be to use JSON, for example, as a way of serializing that data structure. This is great, and it's relatively easy to read, but we can go even further with astexplorer.net and use this interactive tree view, which allows us to click around in the program and actually see highlighted on the left-hand side exactly which part of the tree the source code text corresponds to. The tree is made up of what's called nodes, and the different nodes in the tree have different types. For example, the very top level node is called the program, using the particular type of AST that we care about. And within that program node, there are different other children nodes that make up the rest of the structure. Now that we've cleared out the example text that was generated for us by astexplorer.net to have a blank slate, the next thing we're going to do is we're going to set the transform configuration option, and we're going to pick ESLint from the drop-down. This is going to pop up a couple of frames at the bottom of the screen, which is going to be super useful for us to actually start writing a lint rule in line here in astexplorer.net itself. Before we move on to that though, the next thing we need to make sure we do is we need to change the parser that is being used to parse the source code input on the left-hand side. So where it currently says Babel ESLint, we're going to change that to TypeScript ESLint parser. This setup here now very closely mirrors what we have locally in our NX workspace, and so we can use this to very quickly just prototype what it is we want to create with our lint rule so that you can see all the different elements in action, the AST, ESLint, and the output of the linting, as well as the source code. So let's quickly delete this example rule code that was generated for us and toggle on prettier so that we get some nicer formatting as we're working. On the right-hand side on these bottom panes, we can see the lint output that we're currently getting. So right now, the lint rule is not being fired, and it's showing us the fixed output, but of course right now the fixed output is the same as the input. There is no change by running auto-fixing on this because we currently are not doing anything. Let's start by actually populating the source code of the program we're going to deal with here. So let's set up a couple of examples of variable declarations, which are going to be in the ballpark of what we are going to be checking with our lint rule here. So for control purposes, let's set up a let statement first of all. So let foo equals true. And let's also set up a const statement so that we can see the difference between the two of them. Because obviously we need to pick out here which one of these two is the one we care about. And it's line 3 const bar equals true. But how at the AST level can we tell the difference between them? They're clearly both showing up as variable declaration node types within this AST. So what sets them apart from one another? How can we only target line 3? As you can see here, there's actually a kind property on the variable declaration node. And for the first line, we can see that that's set to let. For line 3, the kind is equal to const. So this is the key property in this particular case that we care about when it comes to differentiating variable declarations, to only look at the const variable declaration statements that we care about. In order to actually target those AST nodes with our ESLint rule, the thing we're going to be returning on this object is a series of methods where their name corresponds to the type of AST node that they're targeting. This will then be used by ESLint internally to resolve those nodes and call your method when it hits that particular node within the data structure when it traverses it. So inside this particular method, we're going to receive as an argument the node itself that we've hit as the ESLint has been traversing the program, and we have access to a context object that ESLint provides to us, which has a report method on it, which allows us to fundamentally tell ESLint, this is a violation of the current lint rule that I'm writing right now. So when we call reports on a particular node, we can give it a message that ESLint will then give to the user as the lint feedback. So usually that would be an error, but obviously with ESLint you can configure a lint rule to show up as a warning instead of an error. But this is the message that will be passed on to the user. This is a great start. We are showing that we've written a valid rule which can be invoked by ESLint, but clearly this isn't yet doing what we need it to do. We don't want it to report on every single variable declaration. We only want it to report on const declarations. We can achieve this in a couple of different ways. Fundamentally, the variable declaration method here is just a function, so we can write some imperative JavaScript code to check whether this node is the right type of node for us. So we can say if node.kind equals const, then call context.report. So in any other case, don't call context.report. So sure enough, now only line 3 will be reported. Const bar equals true will now be reported by the rule, but line 1, let foo equals true, will be ignored because it's no longer applicable and we're no longer calling context.report on that particular node. This works fine and is a perfectly appropriate method to figure out what kind of node you care about, but there is a slightly more idiomatic way of doing this in ESLint using what's called a selector query. So it turns out that not just node types can be specified as the names of methods here. We can also use a more advanced kind of DSL to specify exactly what kind of node with what properties we care about are going to be invoked by ESLint for us. So it's able to resolve more than just the name of the type of a node. It can also resolve certain other properties about it, such as where it lives, its siblings, certain properties of that node, and we can specify that using a CSS-like selector syntax. So here, if I only care about variable declaration nodes, and specifically only variable declaration nodes with a kind equal to const, I can specify that as a selector query. Now I no longer need any logic inside of my function to specify what the kind property is. ESLint will only call this method if the kind property is const. All other variable declaration nodes will not cause this method to be invoked, so I'll never receive the node and I'll never call context.report. And just for completeness sake, let's try quickly changing it to let, and yep, sure enough, that now only targets line 1. To round off our basic usage here within Astexplorer.net, let's just show what it looks like to apply auto-fixing to a rule. All we need to do is add a fix property to this report object, and this will return a function which accepts a fixer argument, which ESLint will give to us. We can use that fixer to apply a fix. So there's a certain few methods that we can call on the fixer object, and here we're just going to call replace text and replace the entirety of the node with some string. So here we can see an example of the fixed output showing our replaced string in place of the original statement. Clearly, again, this is not representative of our real behavior, but this just shows the power of Astexplorer.net in quickly prototyping the behavior we want to see by calling all of the APIs of the ESLint rule and ESLint itself. So let's jump back to VS Code and apply the rule that we've created now to what NX had generated for us. Let's clear out the fixer for now. We'll come back to that in a bit. And we'll notice that because we're using the rule tester from TypeScript ESLint, it's fully typed, and so it's giving us an error related to using message. The reason for this is it's actually much better to use message ID and reference an identifier for a message, which we then group together under the rule definition. So let's change our message in line to be now referencing a message ID. And this is now happy and meets the definitions on the type information. As a reminder, in the spec file, what NX generated for us just so happens to be a const variable declaration statement. So we don't actually need to change this to prove that our lint rule will now cause this test to fail, because it's going to report an error on this statement. We've included it in the valid section, so that's not correct. This should be in the invalid section currently because we're reporting on all const declarations. Because we're using the official rule tester, we can see some very useful information about the failure that we've just had. So we can see, for example, the rule ID, which is the name of our rule that we created, is going to be reporting a particular message, which has been resolved from the message ID that we just created. It's going to be reporting on a variable declaration node type, as we know. And we'll also see the line and column, the range or location information that is relevant for our error. In other words, this is where our red squiggly line would appear in our editor, for example. Let's finalize our rule implementation now. So we'll come back to Astexplorer.net. We can close the ESLint panes down the bottom, and we can get rid of the statement we don't need, which was the let declaration. So let's just look at the const piece. When we need to check if this is uppercase, obviously it's the bar variable name that we actually want to check to see if that's uppercase. So let's look up on the AST what it is on there that we need to actually find within our ESLint rule implementation. As I mentioned before, the great thing about this is that it's interactive. So when I click on bar, it will actually open up the relevant piece of the AST for me straight away. So as you can see here, it's hovering on a piece called identifier. This identifier is, again, a type of node. It's assigned to the ID property of the variable declarator node type, and that lives inside the declarations array of our original variable declaration node. So we have the variable declaration node in our implementation already, so we just need to reach into that node to look up its declarations, and for those declarations, we just need to check the identifier names to see if they are uppercase or not. That gives us everything we need to work with, so let's jump back to the implementation. The first thing we're going to do to make our lives much easier is to bring in the AST type information from TypeScript ESLint. So we can import the TS-ES-tree property, which contains all of the AST node types on it, and we can type our node, which ESLint will give us, appropriately as a variable declaration, and therefore we can get autocomplete on the properties of that node type. So here we can see, for example, the declarations array that we're expecting to see, which, as you can see, is of type variable declarator array. We're going to simply iterate over those variable declarators in the declarations array, and we're going to bring in another utility from TypeScript ESLint called ASTUtils, and this is going to allow us to apply a type guard to that node to make sure that we've got an identifier as the ID property on the variable declarator, and that will then give us the ability to grab the name, which is what we care about for checking if it's uppercase. Just to complete the rule implementation then, if the identifier name is not uppercase already, then we will call context.report, and so that's how this lint rule will actually flag up cases where the identifier name is not uppercase. We would expect our tests in their current state to fail because example is not uppercase. Let's rerun just to make sure. And sure enough, we get the failure. So let's fix up the example so that it is valid. And now everything does pass. You can add as many test cases in this valid array as you want. So let's add a few more relevant examples. And with that all passing, let's turn our attention to the invalid cases. For invalid, we specify the code that should be failing, and we specify an array of errors that we expect to receive for that code. For an error object, it's as simple as providing a message ID if we don't have multiple errors and we need to position them with location information. Speaking of location information, it can be very nice to actually visualize where the red squiggly lines would come in the particular source code you provided as an invalid test case. So we're going to install a utility I created in Angular ESLint for doing exactly that. Even though this is inside of Angular ESLint, it's not actually specific to Angular, and you can bring this into any NX workspace, whether it's using Angular or not. Because I happen to be using Angular here with my preset, I already have some packages installed from Angular ESLint. However, it's specifically the utils package that we need to install on top. I'm going to update them all to the latest version and install the new package. Now that we have that package installed, I'm going to bring in the convert annotated source to failure case utility, and we're going to replace the invalid object here with the return value of that particular utility. So from before, our code gets applied to our annotated source property, our message ID gets applied to message ID, and we can also add a description for the overall test case, which makes reviewing them much easier to see the intent of the author behind what they expect to happen in this particular case. Now, the real power of this utility is the fact that we can go into our annotated source and underline where we expect the lint error to occur using a number of special characters. Have a look at the source code and the documentation for convert annotated source to failure case to see what characters can be used. But for example, the tilde looks like the squiggly line, so it's a perfect character to use in this case. So we can underline the entire statement, which is currently what we're flagging up to ESLint, rerun the tests, and sure enough, they still pass, meaning our location information is correct. Having this visual feedback is so useful because we can see here this might actually be a bit noisy for our users. It might be a bit nicer if this actually only underlined the identifier name, which is actually violating the rule. So in this case, we want to only underline example. If we do that now and rerun the test, we'll see that the test failed because currently we are expecting to underline the entire statement, the entire node of the variable declaration. Let's go into the implementation of the rule and fix this up so that we only flag the identifier and not the entire statement. Now that we have the implementation down, let's go ahead and apply this rule and actually test it out on our real code within our own NX workspace. As a reminder, we need to use the special namespace provided by the ESLint NX plugin, and so we're going to remind ourselves of that in the comment in the lint implementation that NX generated for us, and then we're going to go ahead and apply it to the config at the root, just on all files for now. Then, just to make sure all the changes take effect in our IDE, we can restart the ESLint server that runs within it using the command palette, searching for ESLint restart. So let's just open main.ts and add a failing example here. And just as we hoped, right in the middle there, we have the specific feedback from our workspace lint rule. Constants should be written in uppercase. So this is really useful, really powerful. We didn't need to do any publishing or any packaging. NX has just resolved the rule for us and we get the feedback right there in our IDE. So finally then, to finish this talk off, we're going to cover the auto-fixing that we briefly had in place before but never quite finished off. And so we're again going to approach it kind of in a test-driven development manner where we make the behavior fail first of all, then we implement the logic, and then we make our test pass. So the other thing that comes with this utility, convert annotated source to failure case, is the ability to provide annotated output. And this is just like when we were on Astexplorer.net and we saw the output property in the right-hand side. So here we're going to apply the output we expect to see once we've applied auto-fixing to the source code. As I mentioned, first we're going to make this fail. So let's apply the fixed output we expect to see, but that we haven't yet implemented any logic for. So when we've done all of this, we expect to see const example in all caps equals true. Sure enough, this currently fails because we haven't updated our logic, but now we have something to aim for. As we know from before, to implement auto-fixing, we need to add a fix property to the object we give to context.report. That property is a function, and that function receives a fixer object from ESLint. In this particular case, the fixer object has a method called replaceText that we're going to use, and we're going to replace the contents of the ID node, the identifier node, with the transformed to uppercase version of its name, and that's going to be our replacement that we do. If we rerun the test now, we'll see we haven't actually quite done everything we need to, because it turns out that Astexplorer.net behind the scenes was setting a required property for us we didn't need to think about, but now that we're writing the rule ourselves, we do, and that is namely the fixable property on the meta of the rule that we're creating. So in order to make our rule auto-fixable, we need to set this property, the fixable property, equal to the value of code, the string of code. Having set that, ESLint will no longer throw that error and we can run the tests. However, we're not quite passing yet. One thing I glossed over before was that the white space within the annotated output is important, And the white space is going to line up based on our annotation being removed. So that underline that we applied with the tilde character is going to be removed in the output, and we have to take that into account with our white spacing in the outputs. Otherwise, Jest as the test runner won't match the strings exactly. So if we just adjust that string so that the white space is exact, then we will get the test passing, including autofixing. Now that we have our autofixing logic in place and we've tested it, let's actually use it on our real example of a failure in main.ts. If we activate the quick fix menu now, for example on a Mac I can press Command dot, I can choose the fix option for the particular rule that I created, my uppercase const rule, and if I press on that you can see the autofix gets applied right there in line in my IDE. Naturally, this is not the only way to run linting or apply autofixing from linting, so let's repeat the example using the command line this time. So I'll revert the fix, this time run nxlint. Here we'll see the error, and now I'll rerun, this time with -- fix applied, and sure enough now linting passes, and we can see some of the results here of our uppercasing, which is now generating some warnings for us. But everything about our rule has run, everything now passes, we have linting and testing of lint rules running, and NX is helping us by resolving our rule without us needing to package or publish anything. And that'll about do it for this talk. I really hope you found it useful. You can find me on Twitter at Mr. James Henry, that's Mr. James Henry, and you can ask any questions there that you might have, as well as on the discussions tab of the NX repo. Of course, you can check out nx.dev or the ESLint website, eslint.org, because as I mentioned, anything from the ESLint community you can use when developing these rules in your NX workspaces. I really hope you enjoyed the rest of NX Conf, and I'll catch you in the next one.